Hello everyone, welcome to my YouTube channel B.Tech Last Minute Study Group, and this is my first channel. This is going to be my first video. I am starting with this subject, formal languages and automata theory. In few colleges it is also known as theory of computation. Both are the same. I've chosen to start with this particular subject because this subject is of really it has huge importance not just in your examination paper. It is a complex subject. If you understand, it is very easy, and the scoring in this subject is either full or zero for each question. Like if you attempt a question, if you finish solving the problem, you either get full marks, or if it is wrong, you completely get zero. It's an easy subject. It has little tricks involved, but then it's very interesting. And once you understand the concepts of the subject, you'll start loving it. This is one of my favorite subjects, and hence I chose to start with this. And also, this subject has a good amount of weightage even in your gate paper if you're trying to appear for gate. So, without much further ado, I'd like each one of you to subscribe to the channel and support me as I keep going and including various other subjects. So, we'll start with this particular subject. So, first, what exactly is formal language and automata theory or theory of computation? It is basically a branch of computer science and mathematics. Uh, Now, this particular subject, it involves many functions you'll have to solve. Indeed, it is now whatever you call as computer. This is a complex machine. Now, whatever this complex machine is doing, if you understand it through an abstract machine, that is nothing but formal language and automata theory. That is understanding whatever this complex machine does, which algorithm it is using, how much efficiently it is using that algorithm in order to compute something. That all of that using an abstract machine, you'll try to understand. Now, what is an abstract machine? Basically, abstract machine is a machine in which you do not know what is happening inside. You just know what is happening. Okay, like you have an idea of what is happening, but you do not know how it is happening. As in, take your mobile phone for example. If you open an application, you fill a form and you just submit the form. When you click submit button, you just know that the form gets submitted, but you do not know what kind of HTTP request and response cycle is functioning inside the submission of form, and what kind of JavaScript code or PHP code or whatever is getting executed. That kind of thing is known as an abstract machine. So this flat basically has three subjects: automated theory and language, computability theory, and complexity theory. As per B.Tech regulations, all the regulations of JNTUH, all that you are concerned about is automated theory and language. Now, as you go further, you might or might not have these in your college courses, but for now, our focus is only on automated theory and language. So, what is that automated theory? As we said, it is study of abstract computing devices or machine, and an automation is an abstract computing device. Now, this device needn't be a physical hardware, as I said. It is just an blueprint, you can say, of a complex computer machine. Now, these machines will include inputs, outputs, and states. As you keep going through this chapter, you'll understand that once you give a certain input to an automated machine, it'll either accept or reject that particular input. Now, this input, whatever is given, this accepting or rejecting itself is the output. Now, how does this automation machine accept or reject this input will depend on a number of states that are present. Not number of states, but the states that are present inside this automation machine. The states will basically guide the input into the machine or outside. It'll either stop or not. Say if you are trying to execute a C program, okay? Now in C, your if syntax is like this. If condition parenthesis and you'll write your code here, right? So when you write this, what you want your compiler to do is, first it has to consider each of this. It should first check I and then it has to check for F. Suppose you start from some state Q0. This is the initial state, that is where your if keyword is entering, okay? From Q0, if it is I, then you go to the next state. If it is not I, then you have to go to some state Q2 and this state must say that the string is rejected, as in it is not correct. Now after coming to Q1, it has to go to some state Q2 for F. So IF, now the word is complete, so you got your keyword. So here it should be accepting state. Now this is what is all about finite automata. You have an input and then you get an output. The output is determined by states. These states are nothing but finite set Q, where Q is equals to some Q1 to QF. It depends on the type of automation. Now, these states can be definite, indefinite. We'll see all of that in the coming lectures. Now, we said all about input-output states. The main concept that this automata theory works on is language. We'll see what language is, what strings are, what alphabet is, and everything in the next video. This video is just to give a basic idea to you on what the subject actually deals with. Now, all these languages and whatever you're going to learn in this whole subject is based on one single hierarchy known as Chomsky hierarchy. Chomsky is basically one scientist. He divided the language into four basic hierarchical structure. The first one is regular. This is also known as type 0 grammar. And then context free, type 1, context sensitive, type 2, recursively enumerable, type 3. You'll learn about each of these in the coming lectures. I just wanted to give you a vague idea. Now, as I drew previously, from Q0 it went to Q1, from Q1 it went to Q2, I called Q2 as the final state. Final state is represented using double circles. Now this grammar where there are no restrictions, this is known as unrestricted grammar. Such type of grammar is regular grammar. You'll see what context-free, context-sensitive and recursively enumerable are in the coming sessions. And this machine which will accept or reject an unrestricted grammar is called a finite automata. That means there are finite states in this particular automata. Similarly, for context-free, you'll have different machine. For context-sensitive, you'll have different one. And for recursively enumerable, you'll have different one. That is depicted here. So for your type 0, it is unrestricted grammar. And to accept it, you use Turing machine. And type 1 context sensitive, you'll use linear bounded automata, and then type 2 push down, and type 3 finite state automation. Now, how the course design that I am using is basically from JNTUH Hyderabad, R18 regulation. The subject is part of 3-1 semester, if I'm not wrong. I felt this course design is better because most of the colleges kind of have the similar design. It's just that a few topics are jumbled here and there are few additional topics, and few topics that are present in this might not be present in your college curriculum. If there are any topics that are missing, I just want you to add it in comment section so that I will add those videos as well. And So it'll start with this introduction and then regular expression and then context free grammars with push down automata. And then we'll go to normal forms, closure properties, and the last one will be Turing machines and undecidability problems. Um, I'm always open to suggestions and feedback. You can always write to me to the mail ID of the channel. I'll mention it in the description box. And if you have any exams coming by, you can just let me know in the comment section so that I'll try to finish the videos as soon as possible. Also, if there's any subject that you like me to teach, I would like to hear that as well in the comment section. Before you end up before I end up or wrap this video, I just like everyone to subscribe to the channel. Thank you.